All right, so warm up 76 was flip a coin 8 times, make a table, and record the frequency of the outcome, of each outcome. What kind of probability is this? So, what kind of probability is this after you recorded your stuff, Diego? Okay, so you recorded it and you got your probability. I got that. But what kind of probability is it? We've seen 3 types of probability. Empirical. Hands, have you got that? That is correct because you actually went through the activity to get your probability for each of those. All right. Copy the agenda. Warm up 76. Interest probability. On the last week, we were just left with one small component in regards to the intro to probability, which is one more rule and just one more exercise. So we're going to do that today. It shouldn't take long. But your home plate for tonight is pages 198, 199, number 17 to 21. And we're going to have time to finish here in class, so I included that in this presentation for those of you that are following on Nearpod, on YouTube as well. You can get the code that I'm about to show so you can access the home plate. So once again, warm-up 76 done, interest probability 198, 199, and number 17 through 21. And it looks like it's going to start raining a little bit, just a tiny bit today. Not bad. We'll take it. All right. So, code NXCV6. 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 All right. So, I can identify and compute basic probability. I can identify and compute basic probability on Cornell notes. So once again, we're going to wrap this up today. I can identify and compute basic probability. Make sure you put away your AirPods, cell phones, so you can finish this activity. And then, like I said, you should be able to finish here in class the exercises. So, once again, what is probability? Chance of an event occurring. We got the different types, classical, empirical, and subjective. And then we talked about the formulas for classical and empirical, yes? Some of you wrote like on the formulas on Friday's pop party, you didn't remember the empirical? What? It's frequency over n. Probably the simplest one. Come on, people. Let's go. So we revisited the example with the die, and then we did the law of large numbers. And once again, today we're going to wrap this up. So before we move on, tell your neighbor the difference between classical, empirical, and subjective probability. Tell your neighbor what the difference is from one to the other. Classical, empirical, and subjective. And it looks like Arely's got it. Very good, Arely. Lenny's got it. All right, Lenny, I see you. All right, let's see. Classical versus empirical versus subjective. Did I call on Diego already? Diego, call on someone. Fernando. So classical is pretty much default or theory. So empirical needs to collect data by experience, okay? Subjective personal opinion, which is the one that's the least used because it is not accurate, okay? So we talked about the different terminology. Everybody got these 100% right on Friday on the pop party. Very good. Yeah, you have all that on your notes. Once again, you have the code, which gives you access to all these notes, yes, in case you're missing. And then we talked about the different rules, fairly simple rules, only 4 of them. So today we're going to add one more. Copy this, please. Rule of complementary events. Rule of complementary events. Bless you. So notice here, I'm going to start with the middle one. All right, so in the middle one, it says P of E, probability of an event, equals 1 minus probability of E with a bar. Do you guys see this E with a bar right here? The E with a bar is known as complementary. Complementary. So, this is probably one of the simplest ones that I've seen. I mean, aside from the other one, rule number 4, which is the probability in the event is 1. Look at this one. So let me ask you, what is the probability of tossing the coin and getting tails? Tell your neighbor the probability of getting tails. All right? Probably getting tails. Peyton. What is it? 50 out of 50 or 1 out of 2? Yes? Everybody get that? Yeah? So guess what? That's the probability of the event of getting tails. Okay. So if we use that formula here to find the complementary, so let's see. I'm going to use P of E equals 1 minus, question, what would be the probability of getting heads, everyone? What was it? 1 out of 2 as well. So if that is my complementary, so let's see. P of E equals 1 minus 1/2 is still what? 1/2. Is that what we got for our tails? Yes. So basically it's all saying that whatever the event that you're looking at plus its complementary, it has to equal to what, everyone, at the end? What does it have to equal? 1. Yes? We got it? We're good. All right. Yeah. Yep. Yep. All right. So with that said, copy this one. Example 1. Today we're going to do tree diagrams. This is the last portion that we're going to look at in regards to the introductory part of probability. And it reads, example 1, build a tree diagram for all outcomes of flipping a coin 3 times. So, last week and the previous week, we started with ways of representing data, and some of you just listed your data first. Some of us, after that, I gave you guys a systematic way of doing that, making a 2-way table. Today we're going to use a tree diagram. So, it says, build a tree diagram for the outcomes of flipping a coin. So let's write coin over here. Coin. All right. So, if you flip the coin once, what are the outcomes? Go ahead, Eddie. What comes up if you flip a coin? Heads or tails. Okay, so write that down. That's one flip. Let's go to flip number 2. Let's see. If you flip it again, what are the odds, everyone? What's the probability? Heads, tails. Let's go to the third flip. Again, the probability is what? Head, tails, head, tails, head, tails, head, tails. So that's 3 flips, and these are all the combinations for probability. You're like, I don't see it, Mr. Q. Well, let's list it. Probability combinations. So, you played this game before, right? Tossing the coin? So if you toss it 3 times, what's the first combination? Heads, heads, and heads. You guys see that? All right. What's the second combination? Heads, heads, tails. The next combination. Heads, tail, heads. The next one. Heads, tails, tails. So far so good, yes? Even though it's a simple diagram, guys, this is one of those that gives people like a hard time, which, you know, I get it. Some of us see it different. Let's go to the next combination. What's the next combination? Tails, heads, heads. Then we go to what? Tails, head, tails. Next one. Tail, tail, heads. And the last one. Tail, tails, tails. All right. So if I was to ask you, what are the odds or what is the probability of tossing 3 tails? Probability of tossing 3 tails. What would you say? Going back to our empirical formula, our empirical was what? P of E, F over N. So how many total outcomes do we have? 8. And this is what? 1 out of 8. Yeah? Okay. Is everybody all right? Yeah? You're like, it's Monday, Q. So, my goodness. All right. From 1 to 5, I'll come to bar you with a tree diagram. It's about to get crazy. Yes? We good? 5s? All right. Copy this one then. Example 2. Build a tree diagram for all outcomes of paper, rock, scissors game. 3 turns. 3 turns. Copy that. Build your diagram. I'll give you some time. Leave plenty of space because for this one you're going to need plenty of space. I'm going to start way over here. Paper, rock, scissors. All right, I'll give you some time. Go. All right, here we go. So let's see. Paper, rock, scissors. Yes? From there, paper, rock, scissors. Oh, sorry. Paper, rock, scissors. Paper, rock, scissors. So far so good, yeah? Then from there, paper, rock, scissors. 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 And I'm running out of room. Let's see. Paper, rock, scissors. Paper, rock, scissors. And paper, rock, scissors. So, probability combinations. Paper, paper, paper. Paper, paper, rock. Paper, paper, scissors. Paper, rock, paper. Paper, rock, rock. Paper, rock, scissors. Paper, scissors, paper. Paper, scissors, rock. Paper, scissors, scissors. Then rock, paper, paper. Rock, paper, rock. Rock, paper, scissors. Rock, rock, paper. Rock, rock, rock. Rock, rock, scissors. Rock, scissors, paper. Rock, scissors, rock. Rock, scissors, scissors. And the last ones, scissors, paper, paper. Scissors, paper, rock. Scissors, paper, scissors. Scissors, rock, paper. Scissors, rock, rock. Scissors, rock, scissors. Scissors, scissors, paper. Scissors, scissors, rock. Scissors, scissors, scissors. So what is going to be our N? Tell your neighbor, what would be our N, everyone? Our N for our formula. What's our total? What is it? 27. That is correct. Write that down. On the previous one, N was what, everyone? 8. Yes? All right. So, writing utensils down, look up to the screen. Let's wrap this up so you can get started with our work. So, we started with a coin. Look up, please, or you're going to miss it. How many total outcomes do we have on a coin? 2, is that correct? Heads or tails. Then we flipped it how many times? 3. Stay focused, you're going to miss it. 1, 2, 3. Pay attention to this. We started with outcomes were total of 2. We flipped it 3 times, and our N was what? Okay, let's go to the second problem. We started with how many total outcomes to this game? 3. And then we flipped it how many times? We played it how many times? 3, and our N is? Okay. So, what if I gave you guys a die? And I asked you guys to toss that or to roll it 3 times without making a tree diagram. Tell your neighbor the N for this probability and tell them how you found it. All right, so rolling a die. How many total outcomes on rolling a die? 6. We're going to roll it 3 times. So what is our N? Who went last? Fernando? Pass someone, Fernando? Hands if you got that. That is correct. Tell your neighbor how you got that, please. How did we get that, everyone? Enlighten us. Pass someone, Diego. Okay. Help him out, Areli. You what, I'm sorry? Cube it, because it's 3 chances, so it's 2 to the 3rd power. 2 times 2 times 2 is 8. 3 times 3 times 3. And 6 to the 3rd power, that's 216. All right, so we'll stop right there. So, send me your list of paper, rock, scissors, and then I'm going to send this to your screen. You should be able to finish before the end of the class. Those of you following along on YouTube, I'm going to stop this video right here, so make sure you copy that code that I showed you earlier so you can get started. All right? Talk to you later. Bye.